It's Wednesday, the 13th of September, and it's time for a long overdue Oroville update in the Mighty Luscombe. We've got some pretty good convective activity in the high Sierra today. Should make for some interesting flying conditions. My name's Juan Brown, and you're watching the Blanco Lirio channel. With the lake level down to 734 feet, the Bidwell Bridge here is starting to look like back in the old drought days. They continue to release water out of the reservoir at a rate of 9,000 cubic feet per second to continue to lower the lake level down to 700 feet and beyond. As we approach the Oroville Dam from the backside, you can see the step in the dam, and here on the right hand side of the dam we'll be able to see that mysterious structure, the inlet structure to the power plant that never was. Years ago, engineers considered building a second power plant alongside the Hyatt power plant, but for whatever reason the idea was scrapped. But nevertheless, they built this inlet structure, and it's still visible today when the water's real low. I suspect this was going to be another temperature controlling inlet structure similar to the existing Hyatt power plant inlet. As we bounce our way over the structural concrete power plant, we can see that progress is being made on the Secant cutoff wall. So I'll show you in a minute here where they've got the main power lines rerouted along the new route around the spillway, and they're just about ready to remove the shoe flight connection, the temporary power connection for the Hyatt power plant, so that they can make way for the drilling rigs on the Secant cutoff wall. Remember, during the height of the emergency back in February, as water spilled over the emergency spillway, it threatened to undermine the footings to the main transmission towers of the power lines from the Hyatt power plant. Operators were afraid that if that one tower began to topple with the wires connected, it would pull over like a giant Godzilla effect. It would pull over a whole bunch of the transmission towers. Operators figure they can quickly restring a power line. However, rebuilding transmission lines would take much too long. And remember, you can't operate the Hyatt power plant unless it's connected to the grid. But the Hyatt power plant was already shut down due to the threat of flooding from the Thermalito diversion pool. The fact that the original design had the power lines running right across the face of the emergency spillway is one of the factors that lends me to think that when they designed this emergency spillway, they had it in mind that they were never really going to use it in the first place. I think when they originally designed the emergency spillway, they didn't think of the contingency, or at least give it enough weight, the possibility of a failure of the main spillway forcing the use of the emergency spillway. So today, and you'll see in the subsequent pictures here, the power lines have since been rerouted away from the Hyatt power plant, across the Thermalito diversion pool, down parallel across some existing lines, and then back towards the original right-of-way around the emergency spillway. The work on the Secant cutoff wall is expected to continue into January of 2018, and the armoring of the emergency spillway will be done next year. Now let's bust out the new Canon T6i camera with a 300mm lens and see how each section of spillway is looking. This upper section of spillway will remain in its original condition this year and replaced with structural concrete next year. In the meantime, it's been bore tested and rock bolted down to bedrock. You can see they're using it to store a lot of material for the project, and you can also see the shoe fly connection power lines are still up in place. Will be removed shortly. The next section of spillway, which I referred to as the unauthorized blasting section of spillway, is getting just about filled up with leveling concrete. And you can see some of the structural concrete forms beginning to get formed up. And here's the last section of the upper spillway, where it looks like most all of the leveling concrete is complete, the anchor bolts are in, and a lot of the structural concrete is already in place too, and the walls are getting formed up. This is where the spillway starts a rather steep bend downhill to a 4-to-1 slope, and the end of this structure will meet the roller compacted concrete this year, and at that joint or juncture they're going to install that aeration feature to help prevent cavitation. Introduce air into the system to prevent cavitation. This is also the location of the structural concrete cutoff wall that's going to go all the way down to bedrock to prevent any head-cutting erosion if, in the event, the roller compacted concrete does not perform as advertised during this year's rain season. Remember, roller compacted concrete has a typical strength of 2,500 psi. This application of RCC is going to be one of the biggest applications of roller compacted concrete to date, and as such, engineers are trying to design a hardened layer of the last 12 inches of this RCC by using chemicals that'll give you a strength up to 6,000 psi. Again, the RCC portion of the spillway is only temporary for this year. Next year, the RCC portion will be cut down just enough to make room for the structural concrete, and the structural concrete will be rock bolted into place. Here you can see where operators got to continually create new access roads to get the equipment like this giant pumper truck into position. Next is the roller compacted concrete section of the spillway, the most monumental race of this whole event. Working with just 12-inch level lifts, crews have timed this perfectly to raise the RCC out of the main plunge pool to match the lower spillway RCC at the same time. It's now one continuous single RCC operation to raise 150 feet out of the main plunge pool up to the upper portion of the spillway. This includes the RCC walls, which will be about 12 to 15 feet high and will give this section of spillway a rating of 100,000 CFS for this season. As we look at it from a couple different angles, you can see just how deep of a hole this is. And here's Jeff Peterson from Kiewit Engineering explaining the timing on all this during our construction tour last month. And when do you think you'll get to the top of that hill with RCC?
Last week in October.
All right. An incredible engineering feat. We'll be watching this race very closely. The lower plunge pool has been successfully filled with RCC upwards of 100 feet deep and is awaiting its final 12-inch hardening layer. I'm not sure what the level wood forms are on the inside wall of the RCC walls. The last section of spillway appears to be all done with leveling concrete and rock bolts and has many of the structural concrete panels already in place. The original dentates or diffuser blocks here at the end of the spillway will remain in place and may get cosmetically repaired later. I think in their present form they make a great monument as to what this spillway has been through. At about 100,000 CFS, the water hitting these diffuser blocks at the end of the spillway represents about 1,000,000 horsepower. So let's swing a little wide in the Mighty Luscombe here and see if we can show you how the power lines are going to be rerouted around the spillway. All the bare dirt you see along the sides of the spillway are all going to be trimmed up and treated with erosion control measures before next rain season. Crews continue to dredge out of the Thermalito diversion pool, and I suspect that road along the bottom of the spillway will be removed before next season as well. Now you can begin to see the horseshoe-shaped clearing where the new power lines are going around the spillway. And here's the new path for the power lines out of the Hyatt power plant, bypassing the main spillway and the emergency spillway. So the initial forensics report on what caused the spillway to fail is out, and I'll provide links to that. DWR has provided a final vegetation report on the dreaded green spot on the Oroville Dam and concludes that it's caused by rainfall and is no threat to the dam. DWR also has an initial report on how they're going to inspect the other 1,249 dams administered by the DWR in California. This is just the beginning of a huge engineering watershed event that's going to change how we design, build, inspect, and maintain dams and flood control projects all across our aging infrastructure in America and around the world.